be solving Leetcode number 2050 parallel courses number 3. So we can skip through this, and I'm just gonna go through the examples. Basically, what we want to do is go through take every course, right? But for each node, we have to complete the max node first, and then complete the next node. So here we have 3 and 2 for our first courses we have to take. So we're gonna take 3 because it's more, and then we take 5. So we basically have to take the largest path every time, and that's why we take 3 plus 5, and that's why the output is 8. And then for this example, we can see the max path here would be 3 plus 4 plus 5. That's 7 plus 5, which is 12. This is because for these courses right here, it would take 3 months, but we can take all 3 of these simultaneously. So that's basically why we always take the max path and add that together and return it. See here, it returns 12. So basically what we want to do here is run DFS from the source and get the max path every time, and then go through the neighbors. No, and then start DFS from every node and going through every neighbor and seeing and storing the max path. So we have 3 steps: build an adjacency list. We have a DFS function, and then we have to go through nodes. So we can initialize the adjacency list like this, of a list as its value, and then we're gonna go through the relations list right here and append each source to its destination. So for source and destination in relations, this would be adding 1 to 3, 2 to 3, etc. So I'm just store it here like this: 1 to 3, 2 to 3, and then we just go through, have the adjacency list, and then we have the source, and we're going to append the destination. And then now I'm going to show how we're going to go through the nodes first, because it's more simple. So we go through from the first value to the end value, which is n plus 1, because it's non-inclusive. And then we're going to run DFS on every node and we're going to return the max of our hash map values like this. And I'm going to initialize the hash map later. So here we're going to have the hash map for our max values, and this part's going to make more sense later. So we have a DFS, and we just need the source node. And if the source node is already in our hash map, we just return the hash map's value. So what do we need to do now? We need to run DFS on every starting from the source. So let's have the source node's value with the time. It would be time of source, and then we're going to initialize the result, and then we're going to also subtract 1 because of the indexing, which is kind of hard to explain, but let me write out the rest of the code and explain it later. And we know we need to return the result. So we want to go through the neighbors of the list from the source. So neighbors of the source, and then we want to update the result to the max of itself, which is the beginning source node, and then the neighbor, the time of the source, which is the originals, and then added the neighbor. So after I write down all the code, I'm going to walk through so it makes more sense. And then we have to update hash map's value so that for each iteration we save it to avoid repetitions. Like that. So every time we update the result, we're going to map it. And then let's see if this is correct. So max time is not defined. Oh, I see. So I just, yep, I wrote down the wrong variable name right there. And submit it. Let's see if it's correct. Oh, that's taking a while, but let's see. Time limit exceeded. What did I do wrong? Oh, I don't know what this is. Source and max values. Max values. This is one right here. Return max values. Source. Yep, return. So the time complexity would be O of E plus V, where E is the number of edges and V is the number of nodes in the list. And space complexity would be also O of E plus V, because we have an adjacency list. And we're also using a recursion stack. And E would be the edges, and V would represent the nodes. So now let's go through a walkthrough example. So we already went through this, so we're going through the source and destination of the relations list. We're mapping 1 to 3, 2 to 3, right here. This is how we're doing it. And then we have the max values mapped to avoid repetitions. So first, we're going to have the first time of the source, the original. So the time of number 1 of the first node, we can see is 3, because that's the first value. We're doing the source value minus 1, because wait, let me see. That's kind of hard to explain, but that's just how it works in the code, because when I'm running the test cases, if we don't subtract 1, it returns an error because it's out of range. I'll have to look through that, but so first, the time of the source is 3 months. We can see here, 3. And then we'll go through the neighbors. And here we have the neighbors of the first node, which is 3. So result is 3 already. And then, so it's max of 3. And then time source minus 1 is also 3 plus DFS on the neighbor. So when we run the neighbor value, I'm going to go through 3, and then the value for number 3 is 5. Because here we're going to run DFS number 2 on the third, on the neighbor value, which is third, number 3. And then if we do time of 3 minus 1, which is 2, time of 2, it's 5, because 0, 1, 2, so that's 5. And then this would be 8. And then we would store the source value, the max of the source value in the result. So max values, which is 1 indexed. So the first value is 8. And we'll return 8 for the first time. And then that's it for the DFS. But then we're going to go through the second one. So starting from 1 to n plus 1, we're going to run DFS on number 2 now. So time of 2 minus 1, time of 1, and then time of 1, 0, 1, that's 2. Okay, so now we have time of source minus 1, which is 2. Now we're going to have max of 2, and then 2 plus 5, because DFS, the neighbor of 2, is 3 here, we can see. And then 3's time value is 5, so 2 plus 5, that's 7. The max result right now is 7 for the second iteration. So max values, the second is 7. And then we're going to run DFS again. And this time it has no neighbors, so we're just going to have this run through in time of 3 minus 1, because it's DFS on the third node. 3 minus 1, which is 2, and that's 0, 1, 2, which is 5, and then we're going to store max values equals 5, and then we return the max out of 8. Sorry guys, kind of out of breath explaining. 8, 7, and 5, and that would be 8, and that would be our final result. And let me just fix this, kind of make it look neater. And that is our final result. And yeah, that's basically it. Thank you for watching.